Z transforms, the Z parameters. So not Z transform, sorry. So Z parameters or impedance parameter, when you are talking about some circuit while adding a source here, let's say we are adding some source here, 12 volt, and we are adding some resistance here, 3 ohm, and we say find the power delivered to this resistance by this source using this circuit. So what will we do? We will use the Z parameters, because that thing is straightforward. We find 1 1 1 2 2 1 2 2, and then we find the relation. We put values of voltage and impedance on input and output side respectively. But what if someone says that I am introducing some voltage source on the first side and I am interested in finding some gain or some admittance, not impedance, the admittance. So for that we would be using a sort of hybrid mathematical model. So this thing is better then. So let's examine this circuit and let's use this knowledge that we have gained so far to calculate our hybrid parameters. What is the knowledge that we have gained? One, to let the circuit short on output side, and the second thing is to let the circuit open on the input side. So these are the two rules that we should follow here. So first one, making this circuit short on the second side, on the output side. So V2 is 0. So if V2 is 0 here, this thing is gone and we are left with I1 and V1. So we can write it here as V1 is equal to H11 I1 for V2 equal to 0. So now we can calculate H11. So for that, since H11 is V by I, V1 by I1 is H11, it means that if we calculate the impedance from this side, that would be our H11. Same method as the Z parameter. What we have to do, we should be adding this with a parallel of these two. So adding 12 with a parallel of 3 and 6 will give us H1. So H11 turns out to be 14 in this case. This method is easy, so use this method. You can also say that we want to calculate the voltage on the primary side. This is the second method. The first one is this one that we have calculated the parallel combination of these two resistances and added this third resistance here. This is the second method. In second method we use V is equal to IR method. So V1 is equal to I1 and R1. Now where is this V1 happening? V1 is happening across this and parallel combination of this. So from here to here it is V1. So V1 is something like this. This is our 12 volt, this is our 6, and this is our 3. So the parallel of 6 and 3 would be here. We will remove these things, and this thing will be called 3 parallel 6. So our total impedance of this path is 3 parallel 6 plus 12. So 3 parallel 6 plus 12 multiplied by the current flowing through this path. What was the current flowing inside this? I1, I1, I1. So same I1 is flowing, so I1 और इससे क्या बन जाएगा? V1. So V1 by I1 gives us 12 plus 3 parallel 6. So this is the same thing as we discussed by the method before. Okay, just find the input impedance, and that is our H11. Let's clear up these drawings and writings. So now coming towards this H21, why we are calculating H21? Why is this 1, 2 left? Yes, you people are talking about it right now in a correct manner, that since we have already short-circuited the second port, so by short-circuiting the second port we can find H21 easily. So H21 is actually the ratio of two currents. But how will we calculate the ratio of two currents? By using the current dividend rule. Let's say this is our first current and its sum of part is flowing in the second network. So the second current would be I2 is equal to I1 multiplied by the part in which it is not flowing divided by the total path. So we will use this current dividend rule here. Since we are talking about this input current, so input current is going from here and then dividing here, and this part is the output I2. So I2 is 6 divided by 6 plus 3. We will not talk about this 12. Why? Because the current is here. We are talking about current, not voltage drops. So current is here, and I want a part of this current which is in this branch. So that is actually opposite to our current I1. So minus would be used either with this side or with this. We will use it with this side, and then we will multiply our current I1 and write the branch in which it is not flowing. So this is the current dividend rule. Current dividend rule states that if a branch is bigger, the lesser the current would flow through it. Just think about it and you will know how this relation is formed. So by doing so, we came up with I2 by I1, 2 by 1, I2 by I1, which makes it H21. So H21 is minus 6 divided by 9 minus 2 by 3. So this is how we calculated the H2. So two variables are calculated and two are pending. So let's remove this thing so that we can accommodate our third relation for H12. So 1, 2 and 2, 2 are basically saying that 1, 2 and 2, 2 are saying that we should make I1 equal to 0. This is very important point, that if a current is 0, that means that the circuit on that side is open. So if a current is 0, we will have a voltage appearing on the center of the circuit. So if this is our V1 and current is 0, same V1 would be appearing here. So just keep this thing in mind. Now solve it for V1. So V1 is equal to H1 to V2, and we say that the first part is open, no voltage is provided, no source is provided, this thing is remained open, floating. So for floating, whatever voltage appears here would appear here, unless we connect it to some source or some dropping source जो कि drop करेगा voltage को, resistance etc. So we can say that our main circuit is this 3 ohm and 6 ohm and ground. So this is our V2 and this is our 3 ohm, and this point is our V1 point, and this is our 6 ohm, and this is our ground. And if we want to find V1, which is across 6 ohm, here this V1 is across this 6 ohm, because current is not flowing, so no drop, so this voltage is equal to this voltage. ये मैं बार बार इसलिए कह रहा हूँ क्योंकि वोल्टेज किसी साइड पे अप्लाई ना करने का ये नुकसान होता है कि जितनी वोल्टेज किसी दूसरे साइड से आ रही है वो विदाउट किसी रेजिस्टेंस ड्रॉप के उस सिरे पे अपीयर हो जाती है. सो if there is any resistance in the line, that resistance will not be damaging the voltage. Power lines जो लेट्स से ग्रिड स्टेशन से आते हैं टू आवर ट्रांसफार्मर, तो दीज आर ऑफ किलोमीटर्स लेंथ, 200 किलोमीटर 400 किलोमीटर, बहुत लंबे लंबे होते हैं. सो जब तक इसकी यहाँ पे कोई यूसेज ना हो ऑन द आउटपुट साइड, तब तक यहाँ की जो रेजिस्टेंस है दैट रेजिस्टेंस इज यूजलेस. सो वी कैन से दैट इफ वी डू नॉट अप्लाई एनी लोड ऑन द ट्रांसमिशन लाइन, it will not dissipate any energy except जो इससे लीकेज करंट्स वगैरह हो रहे हैं तो वो हमेशा एनर्जी डिसिपेट करते हैं, ख्वाह ये कनेक्ट हो या ना हो. So those are some corona effects and some leakage currents and some fluxes. So without discussing that, we can say that an open circuit, if we have यहाँ पे जितना वोल्टेज होगा वो सारे का सारा यहाँ पे अपेयर होगा, दरमियान में जो रेजिस्टेंसेस है वो कोई भी ड्रॉप नहीं कर सकेंगे तब तक जब तक हम आउटपुट साइड पे से इस्तेमाल ना करें. तो हम यहाँ पे इनपुट साइड का कंसिडर करें, तो दिस वोल्टेज इज अपेयर हियर. सो वी कैन से using the voltage dividend rule that V1 is equal to 6 divided by 6 plus 3. 6 divided by 6 plus 3 into V2. जो सारा वोल्टेज है V2 का मैक्सिमम, उसका 6th पार्ट आउट ऑफ 9 पार्ट्स वो कहाँ पे अपेयर हो रहा है, 6 ओम रेजिस्टेंस के अक्रॉस अपेयर हो रहा है. सो अगर हम इस इक्वेशन को देखें, दिस इज 1, दिस इज 2 और हमारा क्या है 1 और 2. सो ये जो जगह है दिस इज आवर हाइब्रिड पैरामीटर H12. So H12 is 6 by 9, which is 2 by 3. But this time it is positive. Previous time ये क्या था, ये negative था. Now coming towards this H22. H22 is actually I2 by V2. So I by V is the admittance. Okay, so we can say that it is either the output admittance or it is a hybrid parameter that involves the output values. Okay, so let's clean up this side. Use some shortcut. Okay, so for H22 we are saying that this point is this is I2 and this is H22. So again this thing is 0, which means this thing is open circuited. So we can say that H22 is actually I2 by V2. So if we calculate the resistance of output side and just invert it, we can easily find H22. How will we do that? The output impedance is here, 3 plus 6, which is 9. So this is the Z of the output. If we invert this thing to 1 over Z, that would become Y. So 1 over 9 is that thing. Also, if we check this equation, so I is equal to YV, so I2 is equal to 1 by 9 into V. That makes this thing 1 by 9 into V2 equal to I2. So we can say that by moving this thing over here, for I2 we are moving this thing here, V2. So V2 is under the I2 is equal to 1 over 9 is equal to H22. And this thing is 1 over 9. We can say that we have multiplied Y with V to get I2. So what we did actually, we used two tests, the short circuit and the open circuit. By short circuit we did the parallel path and applied two things, current dividend rule and voltage dividend rule. And after that we use this method for finding our I2 equal to H2 to V2. So you can use your own method, but this one is a bit straightforward, and hence we calculated four values, the 1 1, 2 1, 1 2 and 2 2. For these V2 equal to 0, for these I1 equal to 0. So this is pretty much it. In the next slide we will use the same technique with some basic amplifier circuit from electronics, but for the sake of brevity I will tell you some rules so we can reduce that thing as well. That is not in this course, but let's discuss that thing, because in future you might need that as well. So here is the amplifier circuit. We'll just go through it. In amplifier circuit, two things are important: the input impedance and the output gain. So this is our amplifier, operational amplifier. Its input impedance is termed as Ri. So we replace this circuit by an Ri, and after that the circuit gives some gain on its output side, that gain is input voltage multiplied by some constant